AMA, we're dealing with lesson 1.5, a third day, the IVT, the intermediate value theorem. Got a little typo up there, but that's just fine. Using the intermediate value theorem, the IVT, it requires that a function be continuous. Continuity is the most important thing. Calculus is needed to explain the meaning precisely, and we talked about the 3 conditions of continuity, but we've already said that very basically a function is continuous when its graph can be drawn without lifting the pencil from the paper. That is when the graph contains no holes, that is, no removable discontinuities, jumps, or gaps. Here's something super, super, super helpful. We're going to use this as a time saver. Every polynomial function is continuous. Every polynomial function is continuous. Well, let's jump into the IVT. In mathematical analysis, the intermediate value theorem states that for a continuous function with an interval from a to b, that means that x is between a and b. That's what that notation really means. As its domain, it takes on y values of f of a and f of b at each end of the interval. Then it also takes on any and every value between f of a and f of b at some point. So take a look at this picture right here. Let's say that this is our x-axis way down here, and this is where x could equal a, and this is where x could equal b, and this right here could be our y-axis. And we talked before about the video that I wanted to find where the teacher was driving, starting at 30 miles per hour, and all of a sudden it ended. A video showed that her ending speed was 40 miles per hour, but someone covered up the camera, and you only had a split second, glance that her speedometer was at 30 at a given time, then at 40. What we're going to say is every speed in between had to be achieved at least once. At least once. Sometimes it's possible it could be achieved multiple times. Like you could say, did Miss Joswiak ever travel 35 miles per hour? We guarantee it happened at least once, but it's possible that it could have happened several times, right? So you can see more or less what's happening. So there are 2 important corollaries, follow-ups. If a continuous function has values of opposite sign, going from negative to positive, that means what has to be in between negatives and positives? 0. So that means that we would have a root, also known as a 0, in that interval. That's maybe the biggest application that we're ever going to see. If you see a change from a y value from negative to positive or vice versa, that means your y value had to hit 0. And the image of a continuous function over an interval is itself an interval. That's not as immediate and applicable. Let's do our one problem of the day, just this one, and then we can pick up some homework. We've got this interval right here. Again, please realize that this is saying x is between 1 and 2. X is between 1 and 2. And they're saying, hey, prove that this equation right here has a 0 in that interval. In other words, that it has an x-intercept in that interval. Well, tell you what, would you agree that f of x, the function that we're really looking at, is very special? What do we call 5x cubed minus 2x squared plus x minus 6? What do we call that? It's a polynomial. It's a cubic function. You're right. It's a polynomial and is therefore, you could even put the 3 dots here, continuous on this interval. Wow. That means the intermediate value theorem applies. That means the intermediate value theorem applies. So, tell you what, just as we could have x values, we could also have y values. Now, you don't have to draw a picture. I really do suggest that you draw a picture to make it crystal clear to what is really happening. Let's see what's happening at f of 1. Now, if you plug in a 1 into this function, we'd get 5 times 1 cubed, that's a 5, minus 2 times 1 squared, that's just minus 2, plus a 1 and minus a 6. And what do we get there? You work all that out, you can see that f of 1 is really going to equal negative 2, right? 5 minus 2 is 3, 3 plus 1 is 4, 4 minus 6 is negative 2. Guys, I'm telling you right now, you could even make yourself a little picture right there. The picture is not necessary, but I do think it's going to help. And then we can say, well, what else? We need to find out what's happening at f of 2. Now, f of 2, that's going to be a little bit more work. 2 cubed is 8, and 8 times 5 is 40. 2 squared is 4. 4 times 2 is 8. And then we'd say plus a 2 and a minus a 6. Let's see, 40 minus 8 is 32. 32 plus 2 is 34. 34 minus 6 is 28. Wow. Do you know what you're really seeing? You don't even have to draw this to scale. You could see that plain and simply, you're dealing with a negative y value to start off with. You're dealing with a positive y value to end with on this interval. But our function is continuous. So in other words, when I'm going to connect those points, I can't lift my pencil up. You know, every once in a while, kids will say, do you have a 0? They'll say, here, I'll skip and then I'll come over this way. You can't do that. You can't do that, right? It's a continuous function. That means we have to connect without lifting our pencil up. Now, it is possible, guys, that it could hit multiple times. You know, it's possible. Somebody might say, is it in the realm of possibility you might get something like that? Yes. But we're not even concerned about that. We're going to say, look, bare minimum, I know that I'm going to have to hit y equals 0 somewhere. That means I've got a 0. That means I've got an x-intercept. That means I've got a solution to that equation. So how do we officially write it? I hope right now we're convinced, right? You look at that and you'd say, well, yeah, of course that has to happen, right? Yes?
How do you know the function is?
Well, if it's a polynomial, something where you've got x cubed and x squared, just powers of x added with coefficients, then you know it's continuous. Otherwise, you'd have to show the 3 conditions of continuity are always achieved. You'd have to say condition 1 is f always defined. For any a value, would the limit be defined, and would they always agree? That's how you'd prove it. But for polynomials, we'll just say, hey, we know it's continuous. Well, how do we finish this up? We can say that we know that, negative 2 is less than 0, which is less than 28. We can see what we're writing out right here. We know that 0 is in there. We can say by the intermediate value theorem, there exists an x, or you could even say there exists, now the way they're writing it out, they're not writing out the letter C, but a lot of times in calc books, we can say a C, where C is between 1 and 2. So we're talking about an x value where f of c equals 0. What we're seeing is that's your x value of c. There's some x value that will give the y value that we're looking for. And then we're done. That's officially our proof. Okay? So your homework's going to be the same worksheet, but we're going to do 55 through 58 all, then 63 through 65 all.